So what I've got today is connected devices and using them on your local network. Connected devices, IoT devices, I can use those terms interchangeably. And the other thing that this applies to is if you've got like a hardware lab, like you're doing development on these devices, what network do those live on and how do those interact on your network in the other devices that are on your network as well? So one way to start this off would be like Avelino, let's say before you've done like your recent network upgrades, you've worked with these types of devices before. And like, what's the traditional way that folks typically have this stuff wired up?
It's your basic router from Best Buy. That could be Netgear, Linksys. I think those are the same company nowadays, right?
I think
Asus.
those two. So Cisco, I think, bought Linksys. But yeah, basically the good old fashioned like blue Linksys router that everyone knows about. Yeah.
And these are consumer grade routers, very inexpensive and very easy to set up. You just plug it in and it just works. But there's limitations. We might have a bunch of devices, right? How do we connect more than a handful of devices to a simple consumer router?
Yeah. And so I guess one thing I should clarify too is like, what are these devices as more concrete examples? And so you could think of things like BeagleBone Black that I've got on my desk, Raspberry Pi, things like that you might have as like development kits that you're connecting up if you're working on embedded systems types projects. So that would be kind of on the development side. Then on the consumer side of things, you might have things like your home automation equipment, stuff like your Nest thermostat, smart light bulbs, like Philips Hue type stuff, things like that might need to connect to your network to be able to talk to each other so that you can control those devices over like a mobile phone app. And they'll end up connecting like essentially over your Wi-Fi or maybe directly into one of the router ports in the case of like a Philips Hue gateway or something like that, so that you can actually have control over those types of devices in your house. What happens in this situation, like when those devices are connected up? So like if you just plug one of those devices into, say, like port number 2 here, like what all does that have access to, right? Like what can that device get to?
It's in the same networking space as everything else that is connected to that router physically or wirelessly. And if you have a bunch of devices on Wi-Fi, plus you have some dev kits that advertise, I don't know, their host name as gobbledygook, and it becomes extremely hard to pinpoint the device that you want to work with, right? Especially for work. So that's been a minor pain point, but that ties into how do we, what's a good strategy for compartmentalizing it or splitting up work versus, everything else that is perfectly fine to just be shoved together, that is home or otherwise.
Yeah, exactly. And so to kind of go into like a diagram of what you just described there is when you're working with one of these types of routers, so you've got a couple different ports here. You've got the internet port. You've got these numbered ports in the back, which are essentially switch ports. And I'll explain that in a second here too. And then you've got the Wi-Fi that most folks are probably used to connecting their stuff to. And these switch ports on the back are essentially any device you plug into those can freely talk to any other device. But the Wi-Fi is also rigged up to those ports as well. So anything on Wi-Fi or in any of these ports can all freely talk to each other. Like there's no firewall between them. There's no like hardware boundaries, essentially. Like they just talk to each other. The internet port gets a little more specialized in that case. Like there is a firewall between the internet port and everything else, but you're not plugging one of those devices into the internet port, right? Because your modem is plugged into your internet port. So you got to get out to the actual internet somehow. So this is kind of like that logical diagram of what's going on there. And so what I just mentioned there is we've got the router, we've got its WAN port, we've got the internet connected to your cable modem or DSL modem or whatever, or I guess fiber optical terminal nowadays too. And that's going to have like, this is where all the firewall stuff is going on that keeps stuff from the internet from being able to get into your network easily. But on the other side of that router, where you've got all those LAN ports, all of this stuff in orange here can essentially freely talk to each other. So if you've got your computer connected onto that LAN, you've got your mobile phone connected over Wi-Fi to your router, and say you put one of those IT devices on, like your Raspberry Pi or your Nest thermostat or your Philips Hue gateway, stuff like that. If you've put one of those IoT devices connected up to either one of those LAN ports with a physical cable or over Wi-Fi connected to your router, all of these devices are going to be able to talk to each other, which on one hand is good because that means from your mobile phone, you can get over to your IoT device. But it goes both ways. So now your IoT device also has free reign to get to anything, any exposed ports on your computer, any services that might be exposing ports, especially web services or things like that. Typically, mobile phones are a little more locked down, but in theory, it can get to anything that's exposed on your mobile phone. And likewise, anything else on here. So if you have like a smart TV, if you have a gaming console like an Xbox or something, all of those also follow all of these same rules. Like everything can get to everything. So that's kind of like one of those attack vectors from the other side of this, is that something like a malicious IoT device or a compromised IoT device, if someone were able to get back in through the internet to the IoT device, and we can actually explain how that type of attack works here too. If something were able to get into this IoT device from the internet, they can use that to essentially look at everything else on your network, scan everything else on your network, and anything that's exposed, they can potentially grab and retrieve through that IoT device. So like any files that might be exposed over file sharing, if you've left that turned on, stuff like that as an example.
So you mentioned an attack vector there, and we know that there's a firewall between the internet and the router. What other type of attack vectors can we possibly expect? And this might be slightly more targeted, but from the Wi-Fi layer, we know that Wi-Fi isn't terribly secure. And I know in the past, I've definitely cracked a few, but security at the Wi-Fi layer has come a long way since then, but it's still not the best. So is that a worthwhile attack vector?
Yeah, so there's definitely several different attack vectors there. The first one being, like I mentioned, somebody getting in through the internet, but not necessarily directly getting from the internet into your router. Since these IoT devices connect up to cloud services typically as well, if someone is able to compromise the cloud service that this IoT device is talking to, they might get a tunnel that looks official, like to your router. Your router thinks like, hey, I should be able to talk to this. It looks like a secure tunnel. So if they've got access to that IoT device's cloud services, they could essentially crawl back down your network into the device and get access to it that way. Another way is like what you mentioned with Wi-Fi. There are definitely ways to crack Wi-Fi out there. And there are, I'll say, more and less secure ways to run your Wi-Fi, staying on top of the latest encryptions and having a lot more secure passwords, like using more characters, not using things that are subject to dictionary attacks. So like stay away from common words in plain text, go for, longer passphrases and stuff like that. Those are all great things. But yeah, like Wi-Fi itself, even when it's encrypted, there are ways to snoop and crack it. So that can definitely be something to think about. And another one is even just the physical attack too of the network ports. So if you've got people hanging out in your house, for example, you've got guests over, you throw a LAN party, you do, stuff like that. Also, what's stopping somebody from just coming in and plugging right into one of your ports and getting to stuff that way as well. So there's definitely a host of things to think about there. Did you have any other experience you wanted to share on that point?
Not experience, but I do have another question, actually. From a business perspective, if a malicious actor somehow gains access to the IoT device on your network, and maybe he's not interested in you and your network or anything that could be on your network, but from the business perspective, how dangerous can that be?
Well, there's actually another, as you say, that something comes to my mind that's another common scenario. And even if they're not trying to attack your specific network, bot farms are huge as well. And so maybe they're just trying to install an agent on your IoT device or something that can propagate to the rest of the devices on your network that basically turns all your network devices into a bot farm that goes out and attacks somebody else, some bigger target that they actually care about. And then instead of looking like that traffic's coming from those attackers, it looks like it's coming from you at your house, because it is right at that point. So that's definitely one angle to think of. So there's obviously business consequences around that too. And that's definitely something to think about if you're doing this professionally as well. So if you run your, if you do consulting, hardware development, electronics development, firmware development, that kind of stuff, and you're working with these types of devices, especially out of your house, running, your own shop out of your house or stuff like that. There is a certain liability that you have that you also want to protect yourself from, obviously, of if something goes wrong on one of those devices. I think the short answer to that is, what's good advice for any good business advice is always make sure you're minimizing your exposure there. You don't want to have liability for something like that on the business side. You want to reduce that risk as much as possible. So it's all about keeping good security practices and really understanding. I think technically what that comes back to is really understanding what's going on with the devices and the traffic on your network when you're in that type of position.
Cool. And I guess this is a good way to move into like how we can secure our network physically and from a software perspective. What can we do to secure our devices, our IoT devices, from the rest of the network or the internet itself?
Yeah. So I think the first place I'll start with that is the poor band solution, because not everyone's doing this commercially, or if you're just starting out, you're not necessarily going to have all of the resources to be able to go out there. Resources both in terms of money and knowledge, because a proper setup does actually take a handful of knowledge to be able to set up all the equipment. The equipment has a learning curve. It's not too terrible to get over if you stick with it and just go and work with it. But I just do want to acknowledge it is there. It is something that you'll have to overcome to do this. So the first solution is, what's the quickest way that you can actually get a good balance between security and not having to mess with your network too much, and also doing it cheaply?
Oh, okay. You already have the answer for it.
So here's the solution to that. We mentioned the internet port earlier, and the most bare bones, quick and dirty way to do this is that internet port is the thing that puts up a firewall between your router and everything else, the internet side of the device and the everything else side of the device. And so if you hook two of these together, you can wire them in a way where you create two separate networks where traffic can only flow one direction through those networks to get out to the web and back in. And this will make a little more sense in a second. And the short answer to that is, take the device that you want to run as your secure network. So we're basically, let me back up. We're dividing the network into two zones: a trusted or secure zone and a dangerous or insecure zone, which in networking terminology, you might also see that called DMZ. So we're creating trusted and untrusted zones. and then the internet. And to be able to do that, you take two routers, one runs each zone, and your trusted zone goes down here. And you take that internet port from that router and wire it into one of the switch ports of your untrusted zone. And then the internet from your port from your untrusted zone actually goes up to your modem, basically to the cloud. So this is what it looks like on that logical diagram. So orange is the untrusted network, green is the trusted network. And we're going to wire the internet into the WAN port of that first router that runs the untrusted zone. We can put all of our IoT devices and anything that we don't trust that needs internet access, but shouldn't be able to get down and see the other private devices on our network. We put all that in this zone. Inside of that, we're able to use the second router to create that trusted zone. And this is where its internet port is not actually going directly to the internet. It's putting up a firewall between what's secure, which is going to these switch ports and to its Wi-Fi, and everything else.
A quick question here is, will this work the other way around?
No, not really. And this is a good point for how traffic flows here. So any of the devices in that trusted zone can talk to each other, and they can talk upwards out of this zone. So they can initiate connections outwards. So the mobile phone could initiate a connection to the IoT device. And once that connection is initiated, they can talk back and forth for the lifetime of that connection. And then when the connection is closed, the IoT device can't talk to the phone anymore until the phone wants to talk to the device. Likewise to the internet, any one of these devices can talk straight out the internet through making another hop through this router. And that opens a connection up here. Since the connection is open, anything can talk then straight back down to these devices until that connection is closed and so on. So we're essentially placing a firewall here just to draw this out. So we've got a firewall going here between these two routers. So this IoT device is not able to go this way to get to the phone. It can't initiate a connection back around here because it hits this firewall on the inbound side. So this is like the quick and dirty way to hack like two consumer routers that you can just pick up off the shelf into making a network that's going to be significantly more secure than just that single router option.
Have you run into any hardware that is very consumer friendly, but gives the individual, the user, the flexibility to learn some of the nitty gritty networking stuff that one would need to know to set up like Cisco routers, like the first stepping stone to be able to do that sort of work? I don't know of much, but I do know that there's a router firmware that can potentially unlock a lot of those features in the web UI just to start poking at stuff like that. And the one that comes to my mind is Tomato OS.
So I haven't worked with Tomato. I actually haven't seen Tomato, but I do have some intermediate steps there that I think answer your question. And so the answer is yes, there is definitely a learning pathway to like get through that learning curve from super easy off the shelf, click a couple buttons or click no buttons on like the Linksys style consumer router versus what you were talking about of say configuring your Cisco Catalyst enterprise switch that you can only get into with a command line and a serial cable, and having to actually learn all the command line commands for that switch before it actually works. So yes, there is definitely an in-between. And I did go through that in-between path in my own experience. So I can at least share what I did there. And so one of the good bridges is kind of like what you brought up. There are there are networking appliances out there, so switches, routers, wireless access points that you can buy that have like either graphical interfaces, well, definitely graphical interfaces that you can either get to through a web browser or through desktop software that they provide. So Netgear, for example, has a series of managed switches. The model number is now escaping me off the top of my head, but you can look up their smart switches and managed switches. And those do come with software that you can use, that you can actually use a graphical interface to get through and do the configuration. And they've got help files that go along with it that you can brush up on what the settings do. And there's tons of information about that on the internet for how to do networking around those types of things. So there's a fair amount of support for that type of thing floating around out there. The other thing you can do is there are switches, or there's a networking gear out there with, I guess, what I would call hybrid interfaces, where they can be graphical or they can be command line. You can do either or. And so like the small business, the Cisco small business series switches, which I'm a big fan of, do that. So they've switched up series here, but I think they were like the SG300 series. Basically look for like the Cisco 300 series switches. And I think they might actually be up to like the 350 series now in that line or something like that. My product knowledge is slightly out of date because my equipment has lasted so long from them, which I would say is a good thing, probably. I've easily been running those switches for over 10 years now, and they're still going just fine. So stuff like that will give you both a web interface and a command line interface. And you can use that also to bridge the gap as well. So if you don't know how to do something, if you need to explore, if you're going around just trying to find some settings, if you need a better way to be able to search for the settings you're looking for, that's a really good time to be able to use that web interface and have those visuals to help you navigate around what you're trying to find and how you want to configure something. All of that has an analogous setting in the command line interface. So once you kind of learn the switch from the graphical side, from the UI, you can then use the same switch to start learning the command line side of things. And then there's like, that's kind of an easy way to start bridging your knowledge, because now you know how the switch works, and then you're just learning a new style of interface, but all the concepts that you're doing in that interface then are the same. So you've already kind of got that in your head at that point. And then so like some of the things you can do with the command line when you've got access to that is it doesn't just make manual configuration easier, but automated provisioning of those types of systems. So you can start scripting installs of a broader network infrastructure if you got more than one switch, for example, or what happens if your switch dies and you need to load a replacement. You can start using automated tooling to recover the settings and set the settings in those switches in more of like a bulk provisioning type of sense. You can provision multiple switches at the same time by doing like that type of approach.
And what does that actually look like? Is it just a bunch of like bash CLI-ish scripts, or are we looking at like Ansible playbooks type of deal where there's like plugins that we can use?
Essentially, you've got both, but I know like you've done the Ansible route. I haven't actually. I've looked at the Ansible modules, but I haven't actually done the Ansible route myself. Because I'll say like, to put it into context, I have a fair number of switches, but not too many. I think I have like maybe 5 or 6. So I've got a decent number of switches provisioned in slightly different ways. But one of the ways, like honestly, once I've got the stuff set up, my network at this point changes so infrequently that I'm not typically in there doing management on a regular basis anymore. I'm lucky if I reconfigure like any of the switches once a year. So it's usually less frequent than once a year. And so I'll take the backup files. You can download backup configurations off those switches. And so usually that's what I've got is a backup. So if I happen to have a switch failure, which has also been the other good news, like I haven't had one of those switches die in 10 years yet. So they've got a really good track record. But if I were to have one of those die or something happened or I needed to move a switch around or something like that, I've got those backup files and I can just load those back up onto the switches. And it's a relatively easy process to do that. And I can keep those files backed up locally as well as up in the cloud. And so it's a pretty reliable system for at least what I'm doing. I know you've got some slightly different use cases though, and you have played around with the Ansible side of things. So what have you done on that front?
So I have been successful with Ansible. One of my biggest driving forces has been to document everything as code and have everything completely automated and completely self-described in a few repositories, so that in the case that something fails, which has happened, I've had some servers fail, I can rebuild it in like 5 seconds or something like that. And that was one of my biggest goals. I wanted to not only be able to do that with my workstations and servers, but also with like the networking setup. And I got to a good point. I don't think I ever finished that out, but it was an interesting journey. But backing up a little bit, it very much sounds like unless we want to go into networking as a career, it sounds like it's obviously very important to learn the networking concepts. And if we don't plan on living in networking land for a very long time, it's probably a very good idea to stick with the web UI, unless you want to go all crazy like me and try to do infrastructure as code with everything that you do.
The web UI can get you very far. And I say this from someone who typically operates development things mostly on the command line. So as far as networking goes, like a lot of the products out there, like the Cisco series products, Ubiquiti, some of the Netgear stuff, although I ended up replacing my Netgear stuff with Cisco's line and it worked out better. Don't get me wrong, the Netgear stuff is not a bad product, especially from like a UI standpoint. Like their UI actually works just fine. The long story short, like the Cisco switches, for what I've been doing and like in how I've used those switches, had better port-to-port bandwidth on their backplanes. So they supported, you could push more data through the system. And so when you're doing stuff like AV streaming, which I used to do professionally, at larger scales, when you're trying to push a whole bunch of like HD video streams across a 24 port switch, when that switch does not have the bandwidth on that backplane to be able to actually support all 24 ports going from port to port, you feel those problems in the equipment. And so the Cisco small business series switches were like just better on that front than Netgear, for example, at least at the time I was doing that. So that kind of pushed me down the Cisco route, and the equipment's been great and the interface has been great. So it's what I ended up going with.
Nice. So let's talk about price. Like, how affordable are the small business switches?
Before we go into price, because I think we're kind of covering a gamut here. So this is how the typical setup with just the standard router and what we talked about first. Like, this setup can range you from basically $30 to $100, depending on what consumer router you buy, right? Like you can walk into a Best Buy and pick up maybe not necessarily a Linksys or now consumer Cisco brand router, but I've been so out of touch with the consumer market. I'm trying to think, like, was D-Link whoever was one of the manufacturers in the lower price range, you can get a router for like $30 or $40.
Yeah.
Right on the low end. So if you follow that logic, like your dirt cheap option, you're maybe looking around $60 to $80 or something like that, for the cheap option of just doing this, which is why I throw that out there.
And to paint a broader picture, I think like the most expensive gaming router is probably like $150 or something along those lines.
I have not seen, although I haven't specifically been looking for a gaming router, but for that price point, I personally like Ubiquiti. Their is it the Edge Router X? They have a lightweight couple port, like 2 or 3 port Edge router or something for that around that price point. And those Edge routers are amazing routers. They're very, very good bang for your buck. Yeah, I see. I see you thumbs upping that because you jumped on that bandwagon too at one point, didn't you?
Sure did.
So the other like thing that really plays into the cost there too is something that we haven't broken down yet, which is what are the actual components or like logical components inside one of these consumer routers. And so one of these consumer routers is actually built up of 3 things. We like lightly touched on this at the beginning. So you've got the router portion, and that's really the logic between the internet port and everything else. So physical switch ports and Wi-Fi. And that's where your firewall and stuff like that come into play. It's at this router layer. Then we've got a switch, and that's how you connect multiple devices on the same network segment. And I realize network segment is a new term I'm introducing right now, but it's a well-known networking term if you look it up, but it's essentially all of the devices and stuff that go on a section of your network. All those devices on the network can freely talk to each other without having to go through a router that knows how to send that traffic to a different network. And then we've got the Wi-Fi, which is the radio portion. How do you actually translate those network signals over the air? Because obviously you can't do it if everything is physically wired up. So the Wi-Fi is essentially a network adapter that's transferring those signal to radio waves, and it's internally wired up to essentially another switch port. So all that Wi-Fi traffic is coming back down into the switch, and the switch is distributing that out to the rest of the physical ports on the network. It's connected back up to the router so that traffic can get in and out of that internet port and so on. So once you start moving up into like level of equipment, once you start going the more business or enterprise route, instead of having all of these in one device, each one of these becomes its own physical separate piece of equipment. And that's good in terms of configurability and what you can do with that equipment. But like what you were getting at earlier, when all of these are separate pieces of equipment now, that also means the price goes up because you have to buy separate pieces of equipment.
But that also means that we have some flexibility, right? Because we can decide to spend a good portion of our budget on one slice rather than on all 3, and then upgrade the cheaper pieces of the pie later on.
Yeah, exactly. So that means it's also making your upgrade path and your expansion path a lot more flexible as well. Because let's say you're starting out with only a couple devices on your network, and maybe you only need a 4-port switch. And so you get that to start with, and you get, say, a decent router so that you've got a very configurable firewall, and maybe you've got one that also gives you DHCP. So it's automatically assigning IP addresses to the other machines on your network, and you've got that configured. Maybe you want to do a VPN for tunneling into your network from the outside, and maybe you end up getting a router that supports doing that. So the routers have these different features. Also, configurability of the firewall, like what it actually lets you do in terms of firewall rules, is another really big one. So yeah, depending on what you're doing there, maybe you go for a really feature-packed router to start with, because you don't want to have to upgrade that very frequently. You just kind of want to get one of those and configure it and essentially forget about it after that. And maybe you don't have a lot of devices on your network right now, so you go with a switch with some smaller ports and maybe one Wi-Fi access point. And then as you start growing your network, you can get a better switch, maybe one that starts letting you do VLANs, or essentially these virtual networks that let you split out one physical connection into multiple logical networks that can't cross between each other because the switch has this logic in it now that prevents that. What you can also do with your Wi-Fi network. So out of one of these consumer access points, it's just going to broadcast Wi-Fi to anyone who connects to it, essentially. With a Wi-Fi access point that supports VLANs, the like one access point could serve up multiple SSIDs, multiple wireless networks. And so maybe you've got a network for your trusted equipment. Maybe you've got another one for your IoT equipment and all your connected devices. And maybe you've got another as a guest network. And none of that traffic in the Wi-Fi access point and the rest of your network, if you're doing it with VLANs, even though you might physically connect that Wi-Fi access point back to your switch with one cable, all that traffic is going across separate VLANs, and it's all separated so they can't actually cross. Like the access point and the switch are smart enough to be able to know how to keep that traffic separated, which is another thing that makes them more expensive. So yeah, you've kind of like got these options in terms of features of what you might want to go with here and how that affects like your upgrade and expansion paths. So let's move over here to some of that more discrete equipment, the discrete components that I was talking about. And these are a couple of those examples. So these happen to be some of Ubiquiti's equipment here because I've been a fan of that. Like I said, too, it's worked out really well. So to start with, you might have like different types of routers that you can go with. And the Edge Router X is a really good example. I think I want to say this thing's like right around $100. So it's incredibly affordable for what they give you. And it's really, really configurable. So you can see you've actually got multiple Ethernet ports, but the catch, the difference between this and the consumer router that I showed off is that the Ethernet ports on this are not necessarily switch ports like we saw in the consumer router. These are router ports that you can configure. And so, which means you can put firewall rules between any of these ports and any other ports. So you can start splitting off what network can talk to which other network and which direction that traffic is allowed to go in and which direction it's not allowed to go in. So this can give you a whole lot of configurability for a relatively small price tag, and almost the same price tag, or like roughly the same price tag as a solution like this of putting two routers connected to each other.
Yeah, I just checked and it's $59.
Oh, wow. So it's even come down in price since I last looked. So like that Edge Router X, if you're looking at doing this, like the UI to this does have more of a learning curve than like a Linksys consumer router. But if you're willing to work on that learning curve, this is a very, very good way to go. And then you've got basically like the bigger version essentially of what's in this box. So like you've got the Edge Router Pro. I forget if they're still making the Pro. Edge Router Pro, Edge Router Infinity, and basically like the rack mounted bigger versions, which essentially have more ports. You might have more bandwidth. So you could get like a 10 gigabit router out of each of the ports rather than 1 gigabit per second, which is what the Edge Router X has. So you can get other features like that. But the cool thing with especially like the Ubiquiti stuff is they essentially run the same operating system. So if you've learned how to configure one of these routers, you know how to configure another edge router that's in Ubiquiti's line. So that's a really cool bonus there.
There's also one really good reason to go about an upgrade path versus buying everything, the most expensive stuff up front. And that is you're going to have a backup in case something goes wrong with some of the hardware. You can roll back to the smaller units. That way your mission critical day-to-day work is not fully interrupted. You might just need to like swap it in and that's it.
Totally. Yeah. And that's a really good point because as you start expanding out your network and your systems and stuff like that, that redundancy And that backup, that like disaster recovery plan starts becoming a lot more important because number one, it's harder to just go out to the nearest Best Buy and pick up another router and drop it in your system and call it good, because there was more configuration that you had to do. But also the more stuff that you start running, and especially if you're doing like this professionally for your job, your system downtime becomes lost revenue. Essentially, it's time that you're not able to do your job. It's time that you can't bill for the work that you need to be doing, stuff like that. So that starts becoming a problem. And when you start looking at like, oh, can I just have another $100 edge router sitting around somewhere, and if something happens to the one that's actually running in my system, I've already got the file backed up off the one that I'm using, and I've got it loaded onto my backup router, and I can just switch the cables out and I'm good to go again. Like there can be a lot of value in that. And I guess that is actually how I run my routers in my rack. I have 2 edge routers in there. One runs the system, the other one's the backup. And if something happens to the first one, I have some labeled patch cables that I pull from the first one and I plug them into the second one, and the network's back up and running again. So it's definitely good to think through your disaster recovery scenarios like that. So using like this type of equipment, there's what I would consider like the ideal type of topology for being able to run your connected devices, or that type of what we were talking about, like DMZ or untrusted zone and trusted zone. And you can expand this out further than that, but this is like the minimal concept, and you can always add on to like this general concept as well. This is closer to how I run my network, which is why I really support doing this. Mine is in reality more complicated than this, but this is kind of the basics of how to do that and how to keep your devices secure and on basically keeping your IoT stuff kind of in its own sandbox so it can't get out to the rest of your systems. But that you can also still use it for either its intended functionality, home automation, or whatever you're doing with it. Or if you're a developer of these IoT and connected devices, being able to set up that sandbox so that if you have a compromised device, or just, it's something that you're developing on, that it doesn't have the access to be able to go, like get your files for the project that you're working on or something like that, and go push them up somewhere it's not supposed to. Or actually, here's another great example. Also preventing your coworkers from pulling pranks on you by remoting into your device and using it to mess around with stuff on your network. I was not a victim of that, but I have seen it happen to people. And I'll say it is. So like there is a certain humorous part of it, like seeing somebody get pranked like that and laughing because like the device on their desk is like in the case of one that has like a speech processor, like like basically saying terrible things to somebody, while it's sitting on their desk. Like on one hand, that's a really funny scenario when you just take that for face value. When you really start thinking about the security implications of that, though, I start finding that like really concerning. And this is like why security, like network security and device security, is so important. Because if that was not in a development system, and that wasn't like, our team just like pranking each other, like what if that was an actual attacker? And start thinking about what that person, that attacker who got into that device, what all they have access to. So yeah, number one, like they've got access to like the speech synthesis engine that's able to like play, things out of the speaker. But what happens if this is a device that's monitoring your home, or like sitting in your kid's room or something like that? Like what if someone's able to like flip a microphone on the device and start, like listening to your conversations, or, listening to what your kids are doing, or stuff like that? Like who knows what somebody's doing with that data and that information? Maybe you're having sensitive conversations. Maybe you're saying your credit card number, like to somebody over the phone that you're trying to make a purchase to or something like that. And you've got a device that's essentially picking that up. Who knows what can be done with that information? The other thing around that too, that I mentioned, is what do you actually keep like on your computer and stuff like that. And there are a lot of systems out there that have file sharing, for example, turned on by default. So if you're coming from the engineering side of things and you keep project files on your computer and, the system, source code for the systems you're working on and stuff like that, if someone were to get into one of these devices that's sitting on your network, what can they actually get off your computer? This could be a lot more, it could have a lot more consequences than just somebody getting your photo album off the family computer of like your family pictures. This could be like someone's actually stealing work that is going out to like one of your clients that you're working on, like a product that maybe either like hasn't launched, or there's like it's like a version 2 of a product or a new product line that basically like it's supposed to be secret, and someone's gone in there and gotten the source code, and they're able to, do stuff with it.
So this sounds very scary, especially the part of a malicious actor coming in and downloading or stealing a company's IP. Like us as contractors, we can be held liable. What can we do to protect ourselves other than going dark, going offline for the amount of time that we're working, or,
Yeah. And the simple answer to this is lock your stuff down. Like lock down your network. So it starts with network security. There is a business answer to that I'll mention, but I'll kind of gloss over it in the sake of staying engineering focused. But there is insurance for this type of stuff too. So if you're doing this professionally, you should be insured for what you're doing. I'll say that. But insurance also typically comes with the exceptions of what types of things that policy doesn't cover, or how they don't cover stuff if you did something wrong. So if you were like flat out negligent on how you were storing your data and that gets compromised, you might not necessarily have the coverage you thought you did. So on the business side, like that's a whole other thing to like talk with your insurance provider about that. But ideally, it should never come to that in the first place, because you've actually secured your network and secured your equipment. Like that's really the place to start. And so that's where I start looking at a solution more like this that you can start putting together with those discrete components that I mentioned up here. Like when you start having like a separate router, a separate switch, separate Wi-Fi, you can start piecing those together and configuring those to build a more customizable network that does the same type of thing that we mentioned before. But these are really the right pieces of equipment to do the job, rather than cobbling together two consumer routers. And I do say that this has a little bit more of a learning curve to do it, but it's not that bad. I'll say that. Like there's a learning curve, but it's not that bad. There's also just a little bit of like sticking with it till you get it and go check out. Like there are so many networking resources out there. You also just like checking out YouTube, like Network Chuck, for example, has a ton of good videos on networking. Like everybody has networking videos these days. It's an old topic. So I'm not necessarily saying like too much new information in terms of how you would do this setup. This setup has been done for a very long time. I just haven't seen it being done a lot from a software, firmware, and hardware development perspective. Like I see a lot of developers that are not doing this, that I felt like this is a really good thing to point out for things that you should be thinking about if you're working on products like this, or if you have like a really extensive automation system at home or something like that. This can help lock that kind of stuff down better. One place to start, for example, is we've now broken out the routers that we had over in this type of diagram. We're breaking those out into discrete components, and we're able to configure each of those components instead of physically separate the networks with different cables, like between router to router and stuff like that. We still have physical connections between those devices, but like what I mentioned with the VLANs, those virtual local area networks, we're able to logically split networks while still possibly using the same physical cables. So each one of these pieces of equipment that's smarter now, is able to help facilitate that. So the thing that is going to be pretty standard that you'll see just about anywhere is start with the router, and we've still got the internet, your cable modem, DSL, fiber, whatever, still coming into that router, because the internet essentially at the end of the day is really just another network. So in terms of what your router sees or thinks about or cares about, it doesn't see the internet as something special. It just sees it as another network that it needs to route traffic to. So then we can go through and start creating other networks based off of this. And so what we mentioned before is we have this secure network and this unsecure network, or DMZ, as you might hear it referred to as you start doing more research on this as well. And we'll just make two different VLANs for each of those. So we'll call the secure network VLAN 1. And we'll call the insecure network VLAN 2. And you just set these up between all of these pieces of equipment in the system. So you tell the router, hey, I've got VLAN 1 and I've got VLAN 2. And here's the range of IP addresses on VLAN 1. Basically, you create network segments for each one. So VLAN 1 is a certain set of IP addresses, and VLAN 2 is another set of IP addresses. And I won't necessarily go into the details on that, but again, like if you just start doing the research on what VLANs are, what subnets are, how to set that type of stuff up, there are tons of resources for this on the web. So then you tell your switch the same things too. So you've got a connection between your router and your switch. You could have two physical connections, one physically for each VLAN. That's completely okay. You can configure the router and the switch to work that way. You can also combine them into one physical cable and overlay two VLANs logically on top of that one physical cable. That works too. A lot of router and switch combinations support doing both. So in this case, we've got one cable from the router to the switch, and we're telling it, hey, this carries the traffic for both VLAN 1 and VLAN 2. And the router and the switch know how to keep that traffic separated from each other. So then some of those ports on the switch, we break out to say VLAN 1 here so we can physically plug a computer hardwired into that switch. So like what you were talking about earlier with maybe wanting to stay off of Wi-Fi or not trusting Wi-Fi in some cases or stuff like that. We can do that, and we can just go hardwired straight into the switch. We can tag that port as saying traffic from this port is on VLAN 1. And that computer then is talking on VLAN 1, and it won't have access to, well, I was going to say it won't have access to those other VLANs, but there is a catch once we get back up to the router. We can tell the router what the rules are. So then we've got to deal with Wi-Fi as well, especially for the mobile phone and the IoT device, because most likely your mobile phone is not hardwired into your network. Most likely it's on Wi-Fi on your network. And potentially same with the IoT device. Depending on what type of device it is, it's probably a wireless device. So if we have a smart access point, one that's VLAN aware and can do multiple VLANs. And again, like I've got Ubiquiti up here as an example because I've been using them for a while and their access points work out pretty well. They do have access points that are VLAN aware, and typically you can run four wireless SSIDs off of these, and you can assign a different VLAN to each one of those if you want to. So if we did something like that here, off that wireless access point, you typically only have one cable that's able to feed data into the access point. But since they're smart, you can say one of the SSIDs is VLAN 1, this other SSID is VLAN 2, and you can run those both down the same cable. But again, because the access point and the switch are both VLAN aware, they know of those concepts, internally, they're smart enough to keep that traffic separated. And then the wireless access point can serve each of those VLANs based on the device that's connecting to it, based on which SSID you're connecting to. So when your mobile phone connects up, you're connecting on one of those SSIDs, and it's connecting you up to VLAN 1. And now your phone and your computer can talk to each other because they're on the same VLAN. And obviously both of these can get out to the internet. But your IoT device is connecting up to a dedicated, like, unsecure network. It's your IoT network or your device network there. And so you can now apply rules in the router. So all this traffic ends up going up to the router and then back down if it needs to go between VLANs. And also, like, you can typically program a lot of modern switches to do this too. So if you hear the term layer 3 switch, it means your switch can do this routing logic, but I'll kind of keep that out of scope here. I'll just say that is a thing. It's something you can look up, but I'm just going to refer to all that happening in the router because traditionally anything that's layer 3, if you will, I'll just use that as a buzzword right now. Anytime you hear that, it's router logic that's processing how to handle that traffic and how to route that traffic. So anything that needs to go between VLANs, or essentially is going between networks at that point, hits the router and the router decides what to do with it. And this is where you can start setting up rules in the router, firewall rules of what can talk to what and what gets routed where. And that's really where a lot of the magic in this system happens. So you can start saying things like, this is where like one of the most popular rules of stuff that's coming from the internet that I haven't initiated a connection to can't come back into my network. That's like one of the first things you expect out of any router. That's like one of those essentially like default rules or really like well-known ones, right? But because, like I said earlier, the internet is really just another network. There's nothing inherently special about the internet from the router's perspective. That means you can apply similar rules between these other VLANs, between your other network segments you've got going on here. And so you can start saying things like VLAN 1 can make a connection out to VLAN 2. So your trusted devices can establish a connection to your untrusted devices, but your untrusted devices cannot establish a connection back to your trusted network. So 2 cannot establish a connection back to 1. And so that's how you can start using each of these discrete pieces of equipment and configure them in a way where you're essentially getting the same behavior out of this like router to router system that I mentioned earlier. But now you're really, number one, using the right tools for the job, but they're also typically giving you a better toolbox to do that with because these tools were specifically designed to do exactly these types of scenarios. Whereas this other one here is like more of a hack to be able to get that behavior. Like it works this way, but doing this was really not an intended use case of getting routers like this and doing this. These pieces of equipment were designed for being able to split traffic up across different VLANs, across different networks, and knowing how to get traffic where it's supposed to go and stop traffic where it's not supposed to go.
Now, the big question is, will this setup stop your coworker from spying on you?
So that's a good point, and that's where this depends. To some extent, yes. But to some extent, this is also why you should never trust anyone you work with. No. So what this does not protect against is if there's another service up here, and we'll just call this the IoT service, and this is connected up to the internet, and you've got traffic, or you've essentially got this connection down your stack. I won't actually draw the arrow physically down the stack, but you've got this connection going down your stack, and it ends up going from that IoT service logically to your IoT device. So like this. And actually goes the other way around. So we'll say the IoT device is able to phone home on the internet. So when you turn it on, it establishes a connection back up your network to this service. So what this model will not completely prevent it. So it helps shield the blast radius here, but it will not completely prevent somebody who's compromised this IoT service from doing bad things on this IoT device. This is still vulnerable in that sense, because as far as the router knows, and as far as all these pieces of networking equipment know, this was a legitimate tunnel. And like, truthfully, this is like, it was a legitimate tunnel that was established from the device up to the IoT service with all the proper like TLS encrypted credentials, networking credentials, all that kind of stuff, and like valid security certificates and all that. As far as these pieces of equipment know, like this is a trusted connection. everything says that the connection itself is legitimate because it was. What's been compromised is the traffic going down that existing connection. And there's really no way to know that, like from this equipment standpoint, there's really no good way for it to know whether there's a good guy or a bad guy on the other end of this service. So it can't really stop that part. And that's where these vendors of these devices, these manufacturers that are making the IoT devices, really need to make sure that their cloud services are secure and that they're doing their proper work on that front. That's what really stops this case, is your security at that point is only as good as your device manufacturer's security.
This definitely stops, though, like this stops a malicious actor from accessing other devices such as IP connected webcams or cameras that are on other VLANs from being accessed. But it does not, like you said, it does not stop the malicious actor to take control of the device and any peripherals connected to that device or any services that the device is running or connected to.
Yeah, exactly. So that's how, using this setup and this network topology, we're at least able to set up good security practices on our side of the network to limit the blast radius of what someone can actually do with a compromised device on our network. So we can't necessarily completely prevent the device from getting compromised. Actually, I realized one thing I'll speak to this in a second. There is kind of another layer of security we can put in here too. What this will end up doing is this IoT device, if it gets compromised, it can't go access the file sharing that might be exposed on this computer because VLAN 2 cannot initiate connections to VLAN 1. So it can't go snooping for files over here. It can't do things messing with your mobile phone because it's on a different VLAN. If you were to do like one generic IoT network, for example, like, yeah, maybe this is another IoT device on VLAN 2, and this compromised device could get to this device because they're on that same VLAN. And this is where maybe you want to put similar IoT devices on the same VLAN, or maybe you don't, like what you said with security cameras. So if these are, I'm thinking like thermostats, or if these are essentially like not critical devices, like they're not things that are really going to spy on you if they get compromised. Like it's not too terrible, or there's not a huge like personal threat to you if they get compromised. Maybe it's okay to put a bunch of your IoT stuff on the same VLAN.
It sounds like it might be a good idea to keep, for example, if you're on multiple projects, on different contracts, it might be a good idea to keep devices for each contract on their own VLAN, so essentially separated from each other.
It could be. Mm-hmm. That can be a whole nother can of worms. So I'll just say, yes, it definitely could be. But kind of what you were getting at, just to use the security camera use case. So like, maybe we don't want the security cameras here on the same VLAN as those IoT devices, because if somebody compromised this network, they could potentially get into your IP cameras, and now they can see what you're doing. They can start getting into something that you don't want them to have access to. And in that case, yes, we could create a third VLAN and set up certain rules to this VLAN, and now these devices can't get to this. And in some cases, in the case of like a security camera network, maybe most of VLAN 1 can't even get to that. Maybe you have a firewall rule that says only this computer with this IP address or with this MAC address is allowed to go out and talk to the camera software. And honestly, it's probably not even the camera at that point. You're probably using a DVR that you're connected to on this VLAN. So like maybe my computer has access to the DVR and nothing else. And again, the router is going to be able to govern that when you set up those firewall rules. And maybe the DVR has access to all those cameras on that VLAN, but nothing from any external VLAN, external to VLAN 3, can actually get to the cameras. Maybe you always have to talk to it through the DVR because that's how you're really going to get the footage off, of that system when you need. So yeah, those are definitely good things to be thinking about in ways that you can partition your network, kind of like what we were getting at earlier, to like limit that blast radius if one of those devices on your network there happens to get compromised.
Very cool.
I realized what we forgot to talk about. What happens if this IoT service gets compromised and you've got essentially a bad actor able to send data back down to your IoT device down here? Is there a way that you can monitor and detect that on your network? And from everything we talked about so far, we've essentially said no, but that's not entirely true. So there are certain router appliances that are smarter than that typical layer 3 router that I've been talking about. And like layer 3 in networking terms, to oversimplify it, just means it has the ability to route IP packets. It has firewall rules, stuff like that. And we're talking OSI layers on the networking stack. I'm not going to go into explaining all those, but look up the OSI model and you'll see this like 7-layered cake thing essentially. And there's plenty of information on what that is. The short takeaway here is networking works in layers. And the highest layer, up at layer 7, we have the application layer. And this is a way that you could actually start making sense of some of the traffic coming down from this IoT service, maybe over probably like an HTTP connection or maybe MQTT, but we'll just say HTTP to simplify it right now. And if you have a router appliance that can operate on layer 7 and not just layer 3, so you're able to operate on that application layer, it can start making intelligent decisions about what type of traffic is coming down the network. And it might be able to start doing things like detecting malicious traffic. And I think one example of that would be pfSense. I haven't actually been able to play with pfSense yet, but from my understanding, I think it supports essentially like threat detection and threat management type things. So it can be monitoring the types of traffic and the payloads in that traffic that these applications are sending back and forth, and get an idea and let you know, and essentially shut things down, execute certain rules for when it sees things that look out of the ordinary, for when it sees stuff like this of something that maybe shouldn't look like it shouldn't be on the network, or it looks like it's out of the ordinary. So yeah, I think this was pretty much the gist of what I was going to go over here and what I wanted to share with everybody. And this is typically the way that I've been doing it for a while now. Again, my system is more complicated than this in practice, but it's essentially the gist of it. Thought I'd share that, and we'll see you next time on the next episode of Full Stack Engineering.